Good morning, everyone. So my name is Sunny Jackson Anasani, and my student code is 2024669078. And then I'm going to introduce my fellow members with INTAN, ZAFIDHA, BINTI, DAUD, NATASHA, ANAK, ALVIN, KIELLAND, and IZETTI, SUHAILA, SUKARDIN. So today we're going to present about basement for our case study. Before I start, so allow me to briefly explain what is a basement. A basement is more than just an underground space. It's a functional extension of the building that can use to serve additional living space, storage, and utility area. However, constructing a basement requires careful planning and execution to ensure durability, safety, and comfort. Several key factors must be considered, including excavation technique, waterproofing, ventilation, and utility installation. Our case study will cover 4 topics of it, which is excavation, waterproofing, HVAC, which is and electrical and plumbing services.
Hi everyone, my name is INTAN ZAFIDHA binti DAUD. Let's start with the basics of excavation. There are 3 main methods used in basement excavation. Firstly, we have open cut excavation. This is the simplest method for excavation. It's great for big or open spaces, but the downside is it creates a lot of dust, noise, and can disrupt traffic around the site. Next, there's a top-down construction. This is a more modern approach where excavation and building happen at the same time. It's especially useful in tight city areas where space is limited. Finally, we use a bracing system to make sure the walls don't collapse during the excavation. This system usually includes steel struts or ground anchors to support the structure temporarily. Now, let's talk about keeping basement dry, which is a huge challenge, especially in Malaysia's rainy climate. There are a few types of waterproofing methods. Firstly, membrane waterproofing. This uses bitumen or PVC sheet to block water, but this can sometimes get damaged when the soil is filled back in. And the secondly is integral waterproofing. Here, water-resistant chemicals are mixed into the concrete itself. This gives a long-term protection. And thirdly, surface coatings. These are like a cement or epoxy layers added on top. They are often used as a backup or in less critical areas. For drainage, there are 2 main systems, which is firstly is French drains. These are gravel filled trenches with perforated pipes that help carry water away from the basement. Secondly, sump pumps. These are used where there's a lot of underground water. They pump the water out to prevent the flooding. Let's move on to ventilation. Basements usually don't have many windows or natural airflow. Without a good ventilation, gases like carbon monoxide, volatile organic compounds, and mold can build up, which is bad for both the building and the people inside. There are 3 ventilation methods. Firstly, mechanical ventilation. These systems are use fans and HVAC units to control air quality. Secondly, natural ventilation. This is cheaper but doesn't work well in Malaysia's humid weather. And lastly, hybrid system. These combine both mechanical and natural methods, and they usually give the best results. Lastly, let's talk about electrical and plumbing system, also known as MEP. For electrical system, all the wiring in the basement must be waterproof. It should also be raised above ground level to avoid flood damage. Emergency lights must have a backup, usually a UPS or a generator, so that people can still see during a blackout. For plumbing, wastewater from the basement needs to be pumped up to reach the city's main sewer line. To prevent flooding from outside, backwater valves are installed. These act like one-way doors. They let water out but don't let it come back in.
Good morning. Today, I'll be explaining about the comparative analysis between the 2 projects. The first project is called Pusat Ahmadiyah Islam. It is located at Jalan Bako, and the status for this project is still ongoing work, which in various construction phases. The scope of work is a 1-story building with a basement and a higher level on top of it. The scope covers site preparation, piling, and building construction in general. The budget for this project is 21,017,150 ringgit and 95 cents. The purpose and usage for this project is religious and cultural use. It is mainly made for religious gathering, community event, and education. For the less footing activity throughout the day with a concentration on visitors for prayers, cultural event, and religious activities. For the architecture design, it is traditional and religious design. The architecture is more focused on religious, meaning with features like prayer hall, domes, arch, and decoration in the style of Islam. The goal of the aesthetic is to show Islamic and cultural value. Sustainability could be about using eco-friendly products, saving water, and getting more natural light, but on a smaller scale. It can less focus on high-tech sustainability and more on keeping things simple and in tune with nature. For the basic safety system, these are likely to contain typical fire safety measures, basic security, and surveillance systems that are made to fit the need of religious or cultural facility. The goal of security is to keep the religious artifacts safe and make sure that places of worship are safe. For the parking and accessibility, this project only use simple parking. There may be basic parking for tourists and staff, but usually on a smaller scale. Accessibility element will be made to make it easier for the elderly and persons with disability to get to religious services. For the building system and technology, this project only use simple and useful technology, which focus on essential requirements like heating, cooling, and lighting with a little technology as possible. The sound system are used for prayers and community activities, but not smart systems that are more advanced. Our second project is called Merdeka 118, also called as Permodalan Nasional Berhad 118. It is located at Jalan Hang Jebat, Petaling Street, Kuala Lumpur. The scope of this work is a high-rise structure with complex structural and underground operation, including deep foundation technique, port pile, and basement construction. The budget for this project around 5 million. The purpose of this project, which is a high-rise design, needs strong structural system such as deep foundation pile, reinforced concrete, and steel frame. It is made to handle the weight of office business and the work that goes on in high-rise building. For the architecture design, it is modern, high-tech design including cutting-edge architecture elements like glass, facades, energy-efficient system, and sleek urban look. The focus on creating a skyline that seems like it from the future and a business atmosphere that is high-tech. This building probably include green building qualifications, solar panel, energy efficient system, and smart building technology to lower their impact on the environment. In a business setting, we should focus on becoming more energy efficient, reducing waste, and being more sustainable. For the safety and security system, it uses advanced security system, which this system have features like biometric access on control, CCTV surveillance, fire suppression system, and system for getting people out of a building in an emergency. It needs a lot of protection because it is business and is in a high-rise building. Parking and accessibility in this project use multiple level parking, which is office work, shoppers, and hotel guests all need a lot of parking space. Lots of room for both public and private car with separate loading dock and access for service vehicle. This high-tech building system, this may include smart lift, automated lighting, HVAC system, and even the Internet of Things, which is IoT, to make things run more smoothly. The integrated technology of managing building and meeting the demands of tenants. Now, I'll be explaining about the similarities and difference between the Ahmadiyya Islamic Center and the Merdeka 118. Although these two projects has different in size, purpose, and technology sophistication, they share common engineering strategies, especially in their basement construction method. This building serves completely different function, which Ahmadiyya is a modest religious center, while Merdeka 18 is a towering commercial and cultural landmark. Still, both face similar underground challenges such as deep excavation, groundwater control, ventilation, and the integrations of MEP system. Both projects rely on open-cut excavation. This method involves digging wide, open trenches for easier access to the basement structure. However, as the depth increases, so do the risks, especially in Malaysia, where soft soil and high water tables are common. To manage this, both sides use sheet piles and diaphragm walls. These act as retaining structure to support the surrounding earth and reduce collapse or shifting during the excavation. One of the biggest shared concerns was groundwater spillage. To address this, both projects use multi-layer waterproofing system. These include bituminous membranes for durability, PVC sheet for chemical resistance, and liquid apply coating for flexibility at joint and corners. In addition, they installed a perimeter and other slab drainage system like French drain and some pumps to handle excess water. These measures are essential in Malaysia's humid, raining climate. Basement often suffer from poor air circulation. That's why both buildings took ventilation seriously. The Ahmadiyya Center relied on passive methods like natural air vent, which are energy efficient and suitable for lower occupancy. Meanwhile, for Merdeka 118, it designed for high traffic, long-term use, and adopt sophistication system like HVAC with demand-controlled ventilation. This ensures energy efficiency while maintaining good indoor air quality. So another important area is the integrations of mechanical, electrical, and plumbing or MEP system. The underground environment are prone to moisture, so both projects use waterproof electrical fitting and protect cables, especially in pump room or near drainage. The emergency lighting was installed to comply with fire safety standard, and additionally, because both basements are located below city sewer lines, they required sewage injector pumps to push the wastewater up into the municipal system. Now let's look at the differences. Ahmadiyya Islamic Center is a community-oriented, single-story mosque with an upper level and basement. Its design includes traditional Islamic elements like domes and arch, while Merdeka 118 on the other hand is a super tall skyscraper with 5 basement level and more than 118 floor above ground. It combines futuristic design with cultural symbolism inspired by the nation's careers. From a technology standpoint, Merdeka 118 is far more advanced. It uses beams, smart sensor, IoT-ready infrastructure, and real-time energy tracking. It also includes biometric access, smart parking, and high-end security system. By contrast, the Ahmadiyya Center relies on traditional building methods, manual operation, and community-level security. These are practically and cost-effective for smaller and facility. Now, I'm going to explain about the cost analysis. Let's start with the Ahmadiyya Islamic Center, which has a total of construction cost around 21 million, as shows it in the BQ. For the Merdeka 118, on the other hand, is a mega project with a total cost of estimate at 5 billion. These massive differences highlight the contrast in project, scale, ambition, and the purpose. Despite the cost difference, both projects use similar foundational technique. These include open-cut excavation, multi-layer waterproofing, some pump drainage, and integrations of mechanical, electrical, and plumbing system in their basement. This shows that cost isn't just about complexity, it also depends on the depth, volume, and purpose of the construction. To understand cost efficient, we look at the cost per square meter. The Ahmadiyya Center, being simple and community-focused, is estimated to cost between 2,000 to 250 per square meter, while the Merdeka 118 with high-end finishes and complex system range between 16,000 to 18,000 per square meter. This shows that as complexity and standard increase, so does the cost per unit area. The biggest cost driver is scale. Ahmadiyya has just one above ground floor, one upper level, and one basement, while Merdeka 18 rises 118 story above ground and includes 5 basement level. This required deep excavation, advanced retaining system, and far more material and labor, greatly increasing the cost. Technology is another major factor. For Merdeka 118, it incorporates BIM, IoT system, energy tracking, and smart building technologies. This requires specialized skill and premium material. In example, the Ahmadiyya Center used traditional construction method with minimal automation, keeping costs lower and manageable. The function of each building also affect costs. The Ahmadiyya Center is used for religious and community events, requiring basic finishes and simpler system. Merdeka 118 services serve multiple high-end function, office, luxury, hotel, retail, and tourism, demanding fire protection, access control, parking curtain wall, and more. This significantly raised the total cost. Merdeka 118 must meet strict international safety standards due to its height and public use. These include wind and earthquake resistance, fire suppression system, and backup power. These systems are expensive but necessary. Meanwhile, the Hamada Center follow local safety costs and has much lower risk, reducing regulatory costs. For the timeline and logistics also affect the cost. Hamada was likely complete within 1 or 2 years with local labor and simple supply chain. For the Merdeka 118 took over 6 years with multinational teams and global suppliers, which longer timelines and more coordinations and complex logistics drive up overhead and administrative costs.
Hi, my name is IZETTI SYUHAILA. So today I'll be presenting on the discussions. First is basement construction issues for Pusat Islam Ahmadiyah. So the first issue is water seepage issues. Water frequently collected during excavation, especially after rain. Delayed concrete works and pose safety hazard to workers and equipment. Needed dewatering pumps and drainage systems, which increase time and cost. Secondly, weak and unstable soil. Sandy and soft soil lack strength, causing excavation walls to collapse. Required extra support, as example sheet piling, adding unexpected costs and delays. Risk the safety of workers and nearby structures. The third one is piling misalignment. Some foundation piles were not correctly aligned, it caused the issues with pile cap installation and structural connections. It requires rework and design adjustment, leading to time and material waste. So fourthly, mechanical, electrical, and plumbing conflicts. Poor coordination between structure and MEP design. System like plumbing and cable trays clash with beams and sprinklers. On-site rerouting caused delays and complicated future maintenance. So the fifth one is poor ventilation and access. Limited airflow made the basement hot, dusty, and uncomfortable. Only one small hoist or staircase made materials transport slow. Temporarily, ventilation and better process planning came too late. And the sixth one is safety and environmental concerns. Cramped, wet, and cluttered workplace led to frequent minor injuries. Strict regulations required constant monitoring of dust, noise, and water runoff. Managing environmental impact took extra time and resources. 7. Waterproofing challenges. The basement relied on a membrane and special concrete for waterproofing. Small installation errors could cause leaks but were hard to detect or fix later. Limited testing time increased the risk of undetected defects. 8. Neglected maintenance planning. Key equipment like pumps and electrical panels were placed in hard-to-reach spots, made future repairs and inspections difficult, caused by poor planning under space and time pressure. So the last one is high cost and missed savings. The project became expensive due to its technical complexity. Local materials helped, but cost-saving methods like pre-cast concrete were not used. Missed opportunities for better efficiency and lower labor. So as the second project, which is PNB 118, so there are some challenges that have been gone through, which is firstly deep excavation challenges. Excavation went over 30-meter deep, far below groundwater level, needed to support a massive superstructure and accommodate multiple facilities. Deep digging increased pressure on surrounding soil, risking collapse or soil movement that could affect nearby roads and buildings. Secondly, groundwater seepage and dewatering. High water table and frequent rain caused constant water seepage into the site. Dewatering systems, such as some pumps, well points, had to run continuously. Any failure in these systems could cause flooding, delays, or structural issues. The third one is risk to nearby heritage structures. Nearby landmarks like Stadium Merdeka and Stadium Negara were at risk. Soil movement and ground vibrations could affect their old foundations. Real-time monitoring tools and reinforced retaining systems were used to protect them, adding cost and complexity. The third one is advanced retaining walls and foundation systems. Conventional walls were not suitable due to the basement's size and depth. Diaphragm walls filled with slurry and reinforced concrete were used. Foundation piles had to reach bedrock, requiring precise coordination between teams in a tight site. So the last one is limited space for heavy machinery. Large equipment operated in a cramped and deep site, increasing risk. Safety planning was crucial due to hazards like falling objects and collisions. Temporary systems like lighting, ventilation, access paths were essential to ensure the work in the confined area. So next, I will be presenting on the solutions implemented during constructions. So first one is groundwater control. High water table made it difficult to keep the site dry. Use submersible pumps and well point system to remove water. Surface drains diverted rainwater away from the excavation. Regular monitoring ensured pump performance and safety. So the second one is soil stability and cave-in prevention. Soft soil conditions pose collapse risk. Steel sheet piles and bracing are used to support excavation walls. Instruments like inclinometers detected ground movement early for quick response. The third one is accurate piling work. Precision was crucial to avoid structural misalignment. High technology tools like total stations and skill surveyors ensured accuracy. Regular checks and coordination meetings to reduce errors. So the fourth one is mechanical, electrical, and plumbing coordination. Structural work advanced before MEP plans were finalized, led to conflicts between pipes, ducts, and beams. Resolved through team collaboration, rerouting, and resizing components. So the fifth one is ventilation and safety in confined space. Poor air quality due to dust and equipment fumes. Temporary fans and ducts improve air circulation. Bright lighting, emergency signs, and safety gear to improve worksite safety. The sixth one is waterproofing strategy. Waterproof concrete and membrane sheets were used. Mock-up tests and inspections ensured quality before backfilling. Prevented future leaks and made the system more reliable. So 8. Maintenance considerations, initially overlooked but later improved during the construction. It is added access panels for valve, pumps, and control systems. It helped ease future inspection and repairs. So the last one is cost control through local sourcing. Use locally produced materials like concrete, steel, and etc. Reduce the transportation costs and import delays. Supported local businesses and improve supply chain control. So the recommendations for improvement. First, adopt building information modeling, BIM. Use BIM early in design to improve coordination between all teams. Help detect clashes in plumbing, electrical, and ventilation system before construction begins. Reduce errors, delays, and cost visualizing the full project in 3D. Encourages transparency and teamwork. So the second one is use precast and modular components. Build elements like walls, stairs, and shaft off site in a factory. Safer and faster installation, especially in tight basement spaces. Allows excavation and element production to happen at the same time, and it's saving time. Reduces on-site labor and improve quality control. So the third one is improve quality monitoring. Install smart sensors to track air conditions like dust, carbon dioxide, temperature, humidity in real time. Automatically activate ventilation when needed and alert supervisors. Keep workers safe from respiratory issues and ensures compliance with safety standards. So the fourth one is use eco-friendly materials and systems. Choose sustainable materials like recycled steel and eco-label concrete. Install systems like rainwater harvesting, LED lighting, and energy-efficient fans. Lowers long-term operational costs and helps achieve green certifications like GBI, LEED, benefits the environment and meets modern construction expectations. So the last one is upgrade waterproofing techniques. Use modern solutions like crystalline waterproofing admixtures mixed into concrete. These form permanent water blocking crystals inside the concrete, more durable than surface membranes alone, especially for wet sites. Reduce future leaks, repair costs, and increase the basement's lifespan.
For the conclusion, I believe basement construction should be planned from the beginning with the maintenance access and stability in mind. Real-time monitoring tools and early design coordination such as BIM can reduce error and reward. This can help the contractor and the client to save more money instead of spending too much when they're doing the maintenance and accessibility for the basement. Coordination between structure and NAP teams is crucial to avoid an on-site layout conflict. This is because when we're having a conflict during the during the design, it can make the project delay and can cause LAD to the clients, and we can make time extension for the contractor, which is the time will be extended for the project. Last but not least, the client or the contractor should be aware on the weather during the project construction. Weather preparedness can help to save costs. Temporary cover drainage is essential for avoiding delay in the rainy climax, especially on the December and January.